Hey everyone, welcome back to the channel. Today, we're starting the first big step in building a large language model, and it all begins with learning how to work with text data. So when I say text data, it does not only pertain to just words, letters, but it actually also involves figures, whether it's a number, it's a symbol, etc. So I'll walk you through a simple Python class called basic tokenizer that helps break down text into pieces a model can understand. So this is actually super important because if we don't prepare text correctly, no model, no matter how big, can learn from it. So basically what we do first here is we import the different packages we have to use for this simple modeling or working with the text data. What we use here is actually the different cases in the Philippines. So when I say cases, it's actually about the legal cases decided by the Supreme Court. So it's actually very interesting as far as I'm concerned. And hopefully you guys would be following this lecture because we will be using the legal texts in the Philippines. I just use this one to source data from the repository I have in my local machine. I actually have 646 files, and that is composed of this number of characters. How many is this? This is 16,531,969. So if we're going to have the characters with this much number, then we can see. So we have this GR number, the ID number. The title is The Salazar versus Limita. Then the Ponente is Calio Sr. And we have this just a very snippet of what the case is all about. This is actually a political law case, which is administrative law, blah, blah, blah. So there's a lot. So these are some of the processes we used. It's like, for example, splitting the text, then converting tokens to IDs, and so many more. We are now going to convert all of these different processes into one single class. And this class would be able to give us the different processes. I mean, this class involves different processes that would be able to generate the text that we want. So later on, we're going to have that. So first, we need a Python class that can handle three basic tasks. One is break the text into smaller pieces called tokens, then build a dictionary that maps words to numbers, and then be able to turn numbers back into readable words. So we call this process tokenization, and it's one of the first and most important steps in training a language model. So without this, the model would have no idea how to read or understand our text. When we create an instance of basic tokenizer, we give it some text. So the init, we are still here. The init function immediately calls tokenize, breaking the text into small pieces like words and punctuations. So then it identifies all the unique words and sorts them alphabetically to keep everything organized. And then it also calculates how many different words or tokens we have. So we call this one vocabulary size. So in this case, we just use the vocab, short for vocabulary. Then finally, as you can see in this, we create two dictionaries. That is one for mapping words to numbers and one for mapping numbers back to words. Kind of like a two-way street. One is on the left side and one is on the right side, but the left corresponds to the right. So that number on the left, for example, corresponds to the word on the right. Now let's go to our next step. So we have the tokenize method. So how do we actually split the text into smaller parts, which is actually very important. It's actually basic in any NLP project. So how do we actually split the text into smaller parts? So the tokenize method does this by using regular expression. So basically a smart rule just to split the text by spaces and punctuation marks. Here, we actually have a lot of punctuation marks here. So we have, for example, apart from the white space, of course. So we have this one. This is a bracket. We also have the less than and equals. We also have the quotation marks. So all of these things. So this is actually not that exhaustive. You can add depending on your needs. So this makes sure that commas, periods, and quotation marks are treated as separate tokens too. So because of course in a sentence, when we are talking about text, each has its own meaning. Each has its own purpose and function. So for example, if we're going to ask a question, we're going to use this. If we're going to make comparisons, we can use this. So that's why each one of them is regarded as one token. So after splitting it, it also cleans the tokens by removing any empty spaces left over. So because we have this strip, we don't want that particular space to be regarded or considered as a token because it has no meaning at all. Of course, although in some cases that can be possible when a space has its own meaning depending on a certain context. So this makes sure that every token we end up with is clean, neat, and ready for the next steps. So once we have clean tokens, we need to convert them into numbers. That's why we have here the encode function. Because machine learning models only understand numbers and not text, of course. Even if it's picture, even if it's sound, whatever data it is, we have to convert that into numbers because machine learning or even AI only accept numbers that can be manipulated mathematically. So the encode method first calls the tokenize. So as you can see, we have here tokenize. It is calling the method or the function tokenize to make sure that text is split properly. Then for each token, it checks the dictionary and finds the number that matches the word. So if a token isn't in the dictionary, it skips it to avoid errors. The result is a list of integers, one for each token that fully represents the text. So now you have, if you could imagine it, just imagine it. If you cannot, then just try to imagine. Before, we split the words into different tokens, and now one ID can be mapped into a word, and but by this time, it's going the word is being represented by a certain number. Then step number 5, or the next step, is that we use the decode. So now what if we want to go back from numbers to readable text? That's what decode is for. So it looks at number, finds the corresponding word from the dictionary, and puts the words together with spaces between them. In this process, we actually, as what I've said, map a certain number or the ID to a certain number, and each number represents a certain word. But word cannot be read as a word. So that's why this decode function here again transforms that number into words. I hope that is clear. So it looks at each number, finds the corresponding word from that dictionary, and puts the words together with spaces between them. So then it does a little extra cleaning. So it removes the unnecessary spaces around punctuations like commas and periods so that sentence looks natural. So in this case, we actually have configured the different removal of spaces depending on where it is situated. So for example, this one, before the symbols, this one is after symbols, space before quotes, remove space quotes, etc. Why do we have to do this? Because again, we are dealing with a legal text. It's actually a case decided by the Supreme Court, and it uses a lot of punctuation marks, and that's why we have to use extra processes to remove these spaces. Now we're going to see how it all works in action. So first we create a tokenizer by passing some text, this one. So again, the text is the one that I have presented to you earlier before I discussed this class. Then we encode the text into a list of IDs. So first we use the encode because it's very important for us to transform that into numbers. We want to check if the code works. We can run the code. As you can see, we are given this. So we have these tokens based on the IDs that we have used. That's from 0 to 10. And here, it's actually 11. So we have this kind of token. And that's it for this one. But actually, okay, it's kind of more difficult to really understand what's really going on because our text is actually more difficult to read because of a lot of extra characters and symbols. Let's have a very simple example. So we just use here a simple sentence. She's just a baby. And by using it, then we have these numbers 3, 1, 6, 8, 9, and so on. So we only have a 6 total number of tokens. So 1, 2, 3, 4, 5. So this one represents this represents this one 4, 4, 3, 3, 3 represents just 3, 5, 3, 2 represents A. This one baby is being represented by this one on And of course, this one, period, is represented by 13. When we want to get what each of these ID represents, we can just do this one, decode, and then just call the IDs. Okay, because ID is already defined here. So that's why we have, it's just a baby. So this one is actually working. So why are we doing this? Because before we can train a large language model, we need to turn messy, unpredictable human language into structured data, numbers that a model can actually work with. So tokenization is the first step that translates human communication into something machines can learn. Today, we built that crucial foundation from scratch using just a few lines of Python. Thanks for tuning in. In the next lesson, we'll move one step closer to building our own very mini language model.